Okay, so we talked about K factor yesterday, and K factor is the diagram ratio to the actual ratio in the units, in the same units, right? Today what we're going to look at, all we're going to do is we're going to add one aspect to it, and that is we're going to look at what happens if we use the area. What happens to K squared? What happens to the K value if we increase the sides of something, and then what happens to the area of it? So the easiest way for me to explain this is this. Let's take a 2x4, we'll just say it's inches, doesn't matter for units purposes. So we've got a 2x4 rectangle object here, all right? What is the area of this rectangle object? 8 centimeters squared. 8 inches squared, correct? Okay, so now my K factor then says I want to increase the size of it by doubling it. So I'm going to double each of the sides here. Okay, so then that makes it 4 inches by 8 inches, agreed? What do you suppose happens to the K factor, the K squared factor for this?
Times it by 4.
Times it by 4. So by doubling the K, this is going to increase by a factor of 4. Does everybody agree with that? Okay, so 4 times 8, 32 inches squared. If I take 32 and I divide it by 8, I end up with the value that's 4. It's a pretty simple concept. Okay, so whatever you do to your K, all right, you're going to square it to come up with what the area factor is for your new object. Fair enough? So let's look at the examples in the book. It says determine the area of this quadrilateral to this nearest tenth of a square unit after it is reduced by a scale factor of 1/4. Okay, so the scale factor means that the K value is a quarter. Okay, so we want to determine what the area is going to be of it if the scale factor is 1/4. The area of the quadrilateral to the nearest tenth of a square unit. Okay, so let's look at the keep in mind for a second. When two similar 2D shapes are related by a scale factor K, then the area of the similar 2D shape is equal to K squared, which is the area of the original shape. You can determine the scale factor by which the two similar shapes are related if you know their areas. So the area of the 2D shape and the area of the original shape. Okay, so the first thing I want you to do is more or less find the area of that shape. So that top shape, not the one with the line through it. Find out what the area of that shape is. Okay? So in order to do that, you're going to approximate here because we don't know the actual measurement of those actual squares. So you're going to count the squares to the best of your ability here and count the squares. So it says I determine the area of the quadrilateral. I divide it into two triangles, one with a base of 6 units and a height of 3 units, and one with a base of 6 units and a height of 4 units. So as opposed to counting squares in this case, they actually divided it into two triangles, which the height was 3, this is 6, and the height here is 4. Okay, so what's the area of this triangle right here? What is it? 9. 9? 3, base times height, 6 times 3, divided by 2. 9 units, right? The bottom one is 12 units. So the total then (21 units). Okay, so we've got that. So now, if the area of the quadrilateral is 21 units, so my area and the K, the scale factor is 1/4, all right? I'm going to multiply it by 1/4 squared in order to find out what the area of the new shape is going to be. So then I calculate it by taking 21 times 1/16, which gives me a unit measurement of 1.3 units. Okay, so what I've gone and done here is, doesn't like the cold either. So what I've gone and done then is I'm going to reduce each of my actual measurements by 1.3 in this case here, or actually, sorry, this is going to be the measure of the units, which is 1.3, so I better not put that in there. Just leave it as it was, so that's the, what do they call that? So the area of the 2D, so this is the area of the reduced shape. Okay, it'll be 1.3 units squared. All right, so I don't really need to go through the next one, but all we need to remember is, going back here, is that if you have the scale, they'll refer to this as the scale factor. If you want to work with the area of the objects, it is just squaring the K value, and that's it. And then tomorrow we'll work on the volume of it, and we'll cube it instead of squaring it, okay? So that's all there is for 8.4. And there's not a lot of questions there. There's about 10 questions there. Were there any questions from yesterday that we didn't know? 8.2, 8.3?
After doing the calculations, how do you know what the scale factor should be? Like, how do you range it? Because it says in the back of the book, like, what's a reasonable scale for the diagram? Well, how do you know?
Okay, you asked me which question yesterday, 4?
3.
3? Okay, so what happens here is this. Okay, you take, so in question 3, you have a billboard that is 400 centimeters by 250 centimeters. Is that not right?
Yeah.
Okay, and we want to scale it down. And we want to scale it down to 15 centimeters. And 12 centimeters. So we've got to fit this billboard into here. All right, so we have to find out which scale factor is going to work. So what I do is I start by dividing 400 by 15, and what do I get?
26.66.
So let's say that that's the scale factor for that one. Okay, what about the width here? K is what?
20.83 centimeters.
20.83 is the K factor for that. So what I'm saying then is this: in order to get this measurement to fit into here, okay, if I divided this 250 by 26.66, it would be less than 12. Okay?
Yeah.
If I were to divide this 400 by 20.83, it would be larger than the 15, so it wouldn't fit in there.
Okay.
So that can't be my scale factor then. This has to be.
So then that's just how you leave it?
That's exactly how you leave it, just like that.
Okay.
So your scale factor, in theory, would be 26.66 to 1.
Oh, okay.
Or actually, sorry, my bad. It would be that. Right? Because it has to be reduced. You're going from bigger to smaller. Okay? And so that's all I do. I want to make sure I check both of the measurements first to make sure that they fit when I divide them both, and the one that doesn't fit. So now when I go, so what happens here when I'm reducing, it'll be the larger one. When I'm going from smaller to bigger, it'll be the smaller one so that it can fit. Okay? And then you rewrite it. Because it's a reduction, it has to be less than 1. Alright,
So if it was an enlargement, the bigger number would be on top.
we'll be on top, that's right. Okay? Any other questions today? Alright, so you have 8.4 to finish up this morning. You have lots of time to do all of this.